Hi, this is Group 11, update number 3. Our project is a multimodal recommender system for ontologically mismatched entertainment domains. The presentation will be given by Yash, Max, and myself. Our project consists of 3 entertainment domains that consist of multiple data sets with different file types, different number of files, a lot of different features, a lot of different rows. None of them were really consistent. Our overall goal was to consolidate to a single database, which would make it much easier than trying to run a recommender system based off individual databases for each of the entertainment domain. And we've settled on a single database going forward. So to meet our goal of creating a single database for all of our entertainment domains, it required a little feature engineering. One of the more interesting tasks that we had was the average rating score for each of the domains. The books and movies were fairly straightforward. They had users. They all rated between a value of 1 and 5, and we just calculated the average rating for each of the titles based on the number of users and what the users scored them for. The video games was a little bit more interesting. There was no numeric value for how somebody rated it. There was a value of the total number of positive reviews and a value for the total number of negative reviews. So what we did was we took the total number of reviews and we created a positive percentage. So in the case of the Galactic Bowling that's listed over there, the positive percentage would be 6 divided by 17, which is about 35%. And what we did then was we used a Python function to assign a value based on the positive percentage that was consistent with the overall rating scales that we had for the other 2 entertainment domains between 1 and 5. So if a video game had a positive rating percentage of greater than or equal to 95, it would get the highest value of 5. If there was a video game that had a rating below 15, then it would get a value of 1, which was the low score. This particular Galactic Bowling that I mentioned earlier, with a rating of 35%, would be below 45 but above 30, so it would get a value of 2. And we did that so that way there was a consistent rating or an average rating score or scale that could be used for the recommender system, and it would allow us to consolidate average ratings for all of the domains to one feature rather than break it out into multiple features. Some of the other feature engineering that we did on the different data sets so we were able to merge to a single database, where we ended up combining some of the features within each of the different databases to form 2 consolidated columns to capture genre and categories. This would allow for a list of descriptive words in each of those features to help our chat and recommender system find a title within those different domains that we have that aligned with what the user is looking for. We also created a new feature that actually captured the domain, and because we were using different data sets, like there was nothing that actually said that this is a book or this is a movie or this is a video game, so we added a feature that captured that, which would allow the recommender system to go to the section of the database to look for titles that met the user's interests. And we also had to join the different data frames, and that required converting features consisting of lists to tuples and then converting back to lists after it was joined. For some reason, joining the data frames didn't like it when one of the contents or the contents of a feature was in the form of a list. So we were able to consolidate to a single database after all the feature engineering and merging was done. And below is a screenshot from the output of the consolidated database, and you can see the domain on the left is a new feature, and you have the titles, the average ratings for the different domains, the genre, the different categories. The categories were different ways that things were tagged within each of the different data sets. We also had a specific feature for authors that was specific to books, because they didn't really have anything that was the same as categories. And then for video games, it was pretty important for us to have uh, the operating system as a feature, so that way, if there was a specific operating system that the user used, that it would take that into consideration.
Hi everyone, my name is Yash Anand, and in this part of the project, I worked on refining recommender logic. While implementing our recommender system, we encountered several challenges that affected the accuracy and the usability of our results. Today, I'll walk you through the four key problems we faced and how systematically we solved them to improve our system performance. Our first issue was with the genre filter. Initially, we used substring matching to check if a user preferred genre was present in an item, but this caused an unintended matches. For example, the searching for OR would match for horror. To fix this, we use Python ast.literalval function to parse genre safely from string into the list. This allowed us to match exact genre instead of losing substrings, resulting in far more accurate recommendations. The next issue was the platform filtering. In our dataset, platforms info was often stored like PC and Xbox instead of actual list. This broke our filtering logic because we are treating them as lists. So again, we used astral value to parse them to string field list into an actual list. We also wrap it into error handling to ensure stability. After this, we fix our platform filtering, which results in more consistent and more reliable results. Another problem came up with our rating filtering. When users set a high minimum rating, like 4.5, it would often eliminate all the results, especially in domain with the higher rated items. To solve this, we added a conditional check. If the minimum rating exceeds the known maximum in our dataset, we log a warning. This helped to guide the user without completely breaking the results. It added resilience to the filtering system. Finally, our original sorting method just ranked items by rating. It didn't consider how well items match multiple user preferences. So we created a simple but effective scoring system. It add 1 point for each match, genre, platform, and rating. This allows us to sort results just by rating, not just by rating, but also by how well they match user preferences. It made the output more personalized and more meaningful. In summary, we addressed four major issues. We fixed over-permissive genre filtering, we corrected inconsistent platform parsing, we added safeguard to avoid overfiltering by rating, and we introduced a simple scoring system for relevant based ranking. Together, these changes made our recommender engine much more robust and user friendly.
Recently, we have also updated the structure of our code. We have broken the code down into steps, clearly identifying every step in the process and putting all of the code in between each step. We've also gone through and removed all of the debugging statements, cleaning up the code and leaving only the needed code. We've also gone ahead and removed test functions and other things we've used throughout the time to help us build and things that we just didn't really need anymore. And then finally, we then built helper functions to reduce the redundant code. This is best practices as by having a helper function, we can just use that function multiple times rather than having to go back and retype out the entire function each time. As we have completed the code, we are now ready to begin on the documentation of the code. The first thing we did is create a requirements.txt file. This file contains all of the packages we use in the app to allow for easy installation of all required packages when running the application. We have also created the README file. We've started with the outline, so laying out what we will eventually have built out for the users. We will be providing an overview of the application, usage instructions on how to run this locally, instructions on how the application works, so breaking it down step by step, and finally providing the dataset schema so that users know what data is available to them within the application. As we have now completed the code, our next steps are to finish that README file and package up all the raw code files in a zip to be easily submitted. And then we are going to begin work on the final paper as well as the final presentation. The group will begin filling out the outline and begin splitting up the responsibilities so we are all able to contribute on the final paper and presentation.